Welcome back, dear students. So let's continue with the last part on exercise 10E from direct and inverse variation. So question number 13 says, A and B complete a piece of work in 24 days. Okay, so A and B completes means let's find what is A and B's 1 day work. So their 1 day's work is going to be 1 by 24. B and C can do the same work in 36 days. That is, B and C's 1 day work is going to be equal to the reciprocal of 36, that is 1 by 36. Okay, and A, B and C together finish it in 18 days. That means A, B and C's 1 day work is going to be how much? The reciprocal of 18, which is 1 by 18. Okay, now question is asking, in how many days will A alone complete the work? Okay, so number one, let's find. Okay, so see, together, okay, in 1 day A, B and C does this much of work. Okay, and if you want to find only A's work, you have to remove B and C, right? So to remove B and C, we have to remove the contribution of B and C in 1 day, and you know that the contribution of B and C in 1 day will be this much, isn't it? So therefore A's 1 day work is going to be nothing but the contribution of everyone, which is 1 by 18, and from this 1 by 18 we'll remove the contribution of B and C, okay, which is 1 by 36. Okay, so let's find the LCM. LCM is 36. So divide 36 by 18, you get 2. 2 into 1 is 2, minus 1. So this is 1 by 36. So A's 1 day work is this much, isn't it? So therefore A alone completes the work in how many days? A alone completes the work in the reciprocal of this, which is 36. So A alone can complete the work in 36 days. Okay, so this is my first answer, number one. So next is number two, is you have to find in how many days will C alone complete the work. So C alone means you have to remove A and B, isn't it? So A and B means you have to remove this from this. Okay, so let's find what is C's 1 day work. Okay, so you know, altogether if they work together in 1 day, they can finish this much of work. Okay, so from this we have to remove A and B, right? So A and B does 1 by 24 part, isn't it? So if I remove 1 by 24, let's see how much do we get. Okay, so your LCM turns out to be 72 here. Okay, so divide 72 by 18, you get 4. Okay, so 4 into 1 is 4, minus divide 72 by 3, so you get 3 into 1 is 3. So it is how much? 1 by 72. Okay, so therefore C alone completes the work in the reciprocal of this is how much? It is 72. So C alone completes the work in how many days? 72 days. So this is my next answer. Okay, now let's see the third one, that is A and C together completes the work. Okay, so basically you have to first find A plus C's 1 day work. Okay, so for that what you need to do is, from this total I need to remove what is B's contribution, isn't it? So what is B's contribution in 1 day? Let's see. So do we have B's contribution in 1 day? Is there any B's contribution? No. Okay, so we get, see here carefully, we get B's contribution from this only. You know how? So we will, okay, so first let's find what is B's 1 day work. Okay, so B's 1 day work can be obtained from this. Okay, so this is the part when all of these work together. So from this I'll remove first A's contribution, because I want only B's contribution, right? So let's remove A's contribution. So A's 1 day contribution is 1 by 36. So let's remove that. Okay, and from that I'll remove C's contribution, and C's 1 day contribution is 1 by 72. Okay, so let's quickly find this. So we get, how much is this? So this is okay, so LCM is 72, isn't it? So divide 72 by 4, 18, you get 4 into 1 is 4, minus divide 72 by 36, you get 2. So 2 into 1 is 2, minus, so you get 1 out here, isn't it? So how much is this? So this is again turning out to be 1 by 72, isn't it? Okay, so B's 1 day contribution is this much. All right, so therefore let's see what is A and C's 1 day work. Or else rather I could have done this also, no? Yes, I could have done, or I could have added this and this, A's contribution. Okay, so let's not do this. Okay, so A's 1 day's work is going to be, A and C's 1 day work is going to be, A's contribution is first 1 by 36, and what is C's contribution? Is this much, isn't it? So LCM is 72. Divide 72 by 36, you get 2. So 2 plus 1, so this is 3 by 72, isn't it? So let's do the cancellation if possible. So yes, 3 1s are 3, 3 2s are 6, 3 4s are, okay. So this is equals to 1 by 24. So A and C's 1 day work is how much? This much. So therefore A and C completes the work in, the reciprocal of 1 by 24 is just 24. So A and C completes the work in 24 days. Okay, so this is how we do this kind of sum. So you may pause the video and note down your solution. So let's observe question number 15 now. So here A can do a piece of work in 10 days. So let's find what is A's 1 day work. So all of you know this is going to be 1 by 10. Okay, now B in 12 days and C in 15 days. So B's 1 day work is going to be 1 by 12. Yes, and C's 1 day work is going to be how much? It's going to be the reciprocal of 15, which is 1 by 15. Okay, now all begin together, but A leaves the work after 2 days. That means A works only for 2 days. B leaves 3 days before the work is finished. That means only C is doing the entire work from the beginning till the end, because A is also leaving and B is also leaving. But how long did the work last? We don't know that, so we need to find that. All right, so we'll assume that let the work last for how many days? X days. Okay, now you know A's 2 day work. Okay, so how much part A has done in 2 days? If I add that with B's contributions, now you know B has worked for 3 days less than number of days to complete the work, because it is said that B leaves 3 days before the work is finished. That means if total number of days is 10, then B works for 7 days. Okay, so similarly here, since the work is lasting for X days, B works for X minus 3 days. Okay, so that is B's X minus 3 day work, plus now C is the only person who completes the work, or who does the work for X days, isn't it? So C's X day contribution, X day work. So if A works for 2 days, B works for X minus 3, and C work for X days, then the work is completed, isn't it? So you know the whole work is denoted as 1, isn't it? I hope this thing is clear. So let's see how much is that. Now A's 1 day work is 1 by 10, but A is working for 2, so that's why we need to multiply by 2 here. Plus now B works for, in 1 day B does 1 by 12 part, but B works for X minus 3, so that's why I need to multiply this by X minus 3. Okay, plus now C's 1 day contribution is 1 by 15, isn't it? But C works for X days, so that's why I need to multiply with X. So this is equals to 1. So let's find the LCM then. Okay, so we have, okay, so first let's, okay, so if you want to cancel this, that also can be done. So this is 1 by 5 plus x minus 3 into 1 is x minus 3 by 12 plus x by 15 is equals to 1. Okay, now this is nothing but a system of linear equation. Okay, so you need to find the LCM, solve for it, and find the value of x. Okay, so I am not doing that part, so you can do that by yourself. I want to see this step. Okay, so you will do this by yourself. Okay, and from here you will show that x will be equals to nothing but 7. Okay, that is the value of x turns out to be 7 from this. Now what is the meaning of this? If x is 7, then it means that the work lasts for 7 days. So therefore the work lasts for how many days? X days, which is 7. So your answer will be 7 days for this. Please do this by yourself. Let's see the last question for the day. So two pipes P and Q would fill an empty cistern in 24 minutes. So pipe P fills an empty cistern in 24 minutes. So that's why let's find P's 1 minute work. So this time is given in minutes, so that's why I'll write 1 minute work. So P in 1 minute, P can fill 1 by, the reciprocal of 24 is 1 by 24. So that means in 1 minute P can fill 1 by 24 part of the empty cistern. Similarly, Q can fill in 1 minute the reciprocal of this one, which is 1 by 32 part. Okay, now both the pipes being opened together, so cistern is there, so pipe P is there, this is my pipe P and this is my pipe Q. So together they are started. Okay, now find when first pipe must be, that is pipe P must be turned off so that the empty cistern may be filled in 16 minutes. Now this condition is similar to this particular problem. You know why? Because this first pipe P is working for how many minutes? That's what the question is asking. When the first pipe must be turned off means for how much time P must be working. Okay, so let pipe P be turned off after x minutes. Okay, so we'll assume that. Okay, now according to question we have, see, we are going to have similar thing. Now P is working for x minutes, isn't it? So P's contribution will be P's x minute work. Okay, P's contribution is going to be P's x minutes work. And what about Q? Now Q is working for exactly 16 minutes, isn't it? Because this cistern is filled in 16 minutes, so that's why Q is working for 16 minutes. So Q's 16-minute work. Now when this happens, your work is completed, that is cistern is filled, isn't it? This is filled, so filled means your total work is done, which is denoted as 1. Okay, now what is P's 1 minute work? It is 1 by 24, isn't it? Yes, and so this is my 1 minute work, but P is working for x minutes, so that's why I need to multiply by x. Plus, what is Q's contribution, 1 minute contribution? It is 1 by 32, isn't it? But Q is working for exactly 16 minutes, so that's why I need to multiply with 16. So this is equals to 1. So again, we will find the value of x. So let me do this by myself. Okay, so this is 1x by 24, right? Okay, so this is 1 by 2. Let me take this over there, so it becomes this much. Okay, so 1 minus half is half. So we have x by 24 equals to half. So from here, take this 24 out there, so you get 24 by 2, which is 12, isn't it? So that means we know the value of x, which is 12. Okay, that means pipe P must be turned off after 12 minutes. Okay, so therefore pipe P must be turned of after a 12 minutes. Okay, so this is how we do the sum. So you may pause the video and note down your solution. Thank you very much.